Hello everyone, welcome to Team 7's final project presentation. For this project, the team had to design a PID controller for an inverted pendulum system. Our team members were Pedro Fernandez Jr., me, Rafal Klecha, Lathal Sakal, Louis Bayrat, Robert Vega, and Moeen Askul. As a summary, we had to design a controller for a closed-loop system that provides current that powers a motor, and this motor then results in an applied torque to the inverted pendulum. The design controller must meet the design specs established by the customer. These design specs or system requirements are 0 steady state error, less than 10% overshoot, and less than 2 seconds of settling time. First, before we were able to achieve those, we had to make assumptions in order to figure out the math behind this problem. So our assumptions were small theta, 0 initial conditions, linear spring, a linear damper, a massless rod, the system is frictionless, the pendulum at the end of the rod is a point mass, and the rod is rigid. Some challenges we had to obtain transfer functions. We had to examine the step response for the system. We had to linearize the equations, and the transfer function was made from 3 component systems. So here we can see our block diagram. We have a controller in a plant, and then the output angle is monitored and adjusted as needed. So to obtain the system transfer function, the team used MATLAB in order to combine the controller and plant into one transfer function. We then used MATLAB functions to analyze our results. We also used MATLAB to modify controller gains in order to meet the system requirements. So here we can see our code. We first started with values being assigned to the controller gains for a PID controller. So we needed 3 values, one for KP, KI, and KD. We chose 50, 775, and 50. Next, the plant transfer function was introduced, which came from the previous 2 projects when we did the math earlier. Next, using the PID function, we created a controller using the assigned values for KP, KI, and KD. Next, the closed loop transfer function was created, and this transfer function was analyzed for a step input using the step and step info functions. And finally, the frequency response of the system was analyzed. Here we can see the results from the code in the previous slide. On the left, we see our plant transfer function, our controller transfer function with KP, KI, and KD values below. And we also see the TS, which is our closed loop system transfer function. As you can see at the bottom, our system achieved a settling time of less than 2 seconds, 0% overshoot, and 0 steady state error. And the time response graph will be shown on the next slide. So here is our step response graph and our bode diagram. Once the transfer function was plotted, both the step response and both bode diagrams were examined to readjust the results to our specified requirements. The step response shows that the settling time received from the controller was 1.886 seconds. The bode diagram shows the frequency response of the controller along with the magnitude and the phase shift. So here are our logistics. Pedro did the transfer functions. I did the MATLAB code and the results. Lath did the introduction and helped me with the results. Louis did the assumptions and the acknowledgements. Robert did the report method and did a lot of work on the presentation. And Moen helped with the intro and the conclusion. So to conclude, by systematically increasing or decreasing the required values within the PID controller transfer function, so the KI, KP, and KD values, We were able to find the ideal equation to reach the constraints of the project, which was a settling time of less than 2 seconds and an overshoot less than 10%, and also zero steady state error. In the future, the controller can always be improved, but for now, we're happy as a team with it since it meets all the system requirements. In our careers as engineers, this project would be useful since it gives us exposure to creating a controller system with given constraints to meet. We'd also like to thank the professor and the TAs for helping us out through the semester. And if anyone has any questions, you can go ahead and ask them. Thanks, everyone.